So here we have intrinsic reactivity ratio in free radical chlorination of alkenes, which is primary, secondary, tertiary. I hope you know these symbols. So these are symbols for degree of substitution. 1 degree of substitution, that means primary, 2 degrees secondary, 3 degrees tertiary. So intrinsic reactivity ratios are 1, primary, secondary to tertiary, 1 to 4 to 5. So in free radical chlorination of 3-ethyl pentane, what are the possible monochlorination products and what is their expected ratio and expected percent yield? So it's a good idea to draw a condensed formula rather than just a line formula, because we will need to count hydrogens, how many of each type of hydrogens are there. And so this is the compound 3-ethyl pentane. And so you can see it has high degree of symmetry. Symmetry is easier to see from a line formula. You may want to operate with both formulas. So basically there are 3 ethyl groups that are bonded to 1 carbon atom. And so when you count primary, secondary, tertiary carbons, and then in turn, of course, hydrogens bonded to those carbons are primary, secondary, tertiary, you can see that there is one tertiary hydrogen. That's hydrogen bonded to tertiary carbon. That's this one. That's tertiary carbon. Carbon bonded to 3 other carbons is tertiary. So this is one tertiary hydrogen. There are 6 secondary hydrogens. Those are CH2 groups. These CH2s have to be shown vertically. There is no room to show them differently. So CH2, 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 6 secondary. These are carbons bonded to 2 other carbons. Those are secondary carbons. So there are 6 secondary carbons. And we have 3 methyl groups, 3 CH3 groups. There are 9 primary hydrogens, 3 primary carbons or 9 primary hydrogens. And so ratio of each product, how much we would expect each product to form, is number of hydrogen atoms of each type multiplied by intrinsic reactivity. And so, of course, intrinsic reactivity is relative ratio, so it's always 1 to something. Lowest reactivity is set as 1, and rest relative to that 1. So primary has reactivity of 1. There are 3 possible products, of course, because replacement of primary carbon gives 1 product. Any of these 3 primary, it's the same compound. Replacement of any of the secondary, this got cut off. Let's fix that. Replacement of secondary gives second product. Now what's going on here? Something is invisible here. Okay, so that's been fixed. Secondary, so any of those secondary hydrogens gives the same product, and replacement of tertiary gives a third product. And so what are the ratios of the 3? We have 9 primary hydrogens, and we multiply that by intrinsic reactivity. That's 1. For primary, it's 1. So 9 times 1 is 9. So you would expect relative ratio of this compound, 1-chloro-3-ethylpentane, to be 9. Then, for secondary, intrinsic reactivity is 4. And there are 6 secondary hydrogens. So 6 times 4 is 24. So you would expect relative ratio to be 24. And finally, tertiary. So secondary is 2-chloro-3-ethylpentane, and tertiary 3-chloro-3-ethylpentane. We have only 1 tertiary hydrogen, and its reactivity, intrinsic reactivity, is 5. So 1 times 5 is 5. So relative ratios are 9 to 24 to 5. And so on the test, if you were typing it up, you would simply type up 9 to 24 to 5. If you are asked to calculate percent yield is amount of the product, that's relative amount, 9, 24, or 5, divided by total. So sum of these 3 multiplied by 100. So to calculate percent yield for the first one, 1-chloro-3-ethylpentane, it's 9, divided by total, all 3, times 100, that's 24%. So you would expect this one, 1-chloro-3-ethylpentane, to form in 24% yield. Second one would be, you would simply plug in here 24, and you would end up with 63%. And for the last one, you would plug in 5, and you end up with 13%. And so those are expected yields. Of course, if you carry actual reaction, it's unlikely that you could get only monochlorination. There would be other byproducts like dichlorination and so on, and some reaction termination products. But this is idealized case, and that's what you would be expected to do on the test. On the test, most likely, you will only have to report ratios. But you could be asked to calculate percent yield, depending on the time, how much time I give you for the test, because I calculate how much time you will have on the test, how much time you're expected to spend on each question, and if there is enough time, I may ask you to do a percent yield calculation. Okay, are there any questions about this one? Let me see if there are any typed up. No? Okay. Of course, you can always ask questions later if you don't want to be part of the video. Question number 6. How many different products can be formed in a free radical monobramination of ethyl cyclohexane? So monobramination or monosubstitution means that only one hydrogen is replaced each time reaction occurs, and that's the product. So how many different products are possible? We have to simply look at how many different hydrogens are there. You may want to draw simply a line formula, and then look what are different hydrogens. So we have one methyl hydrogen labeled as A. Different types of atoms, like hydrogen atoms or carbon atoms, are indicated by letters, not the numbers, typically. So A would be CH3 methyl group, and that one is unique. There are no other such methyl groups, so that's one type of hydrogens. Then this methylene group, CH2, is second type. There is only one CH2 group outside the ring, so that's it. And then we have CH, tertiary carbon, right here, C, that's third type. Now these two CH2 groups that are part of the ring are identical, labeled as D, because each of them is next to this ethyl substituent, next to the carbon with ethyl substituent, and to this part of the ring. Same goes for E. Those are identical CH2 groups. And finally, F is unique. Or if you draw a line through the middle of the ring, this part of the ring would reflect to the other part. So there is symmetry in the ring. So we have two pairs of CH2 groups that are identical. And replacement of any of the hydrogens in them would give the same product. So when you count these, there are 6 different types of hydrogens. And so replacement of each type of hydrogen with bromine would give 6 different monobramination products. And so if you were answering this question or test, you may stop here and simply provide your answer as 6. If you want to double check, but that will take you much more time, you may want to draw all 6 products to make sure they are different. But that will take quite a bit of time. Still, it's not a bad idea as an exercise. And ultimately, if you want to make sure that some compounds are not identical, that they are different, you may want to name them. For example, this compound, if bromine is on this carbon here, they would be named the same way. 1-bromo-2-ethyl cyclohexane. Same bromine here, 1-bromo-2-ethyl cyclohexane. If the name is the same, they are the same compounds. Or 1-bromo-3-ethyl. Bromine could be here. So, but that takes time. So it's a good idea to know how to do questions quickly. And then if you have time on the exam, you can go through this entire exercise. And I will talk more about it next day when I tell you about exam taking strategy. So you may want to go quickly, answer the question like this, and that's it. You know, you have 6, you have an answer. And then if you have time left over on the exam, you can double check that answer. Although for this one, if there are 6 different carbons, that means hydrogens are attached to them, form 6 different groups of hydrogens. Replacement of hydrogen from each group gives different product. There must be 6 products, no more, no less, provided that each carbon has a hydrogen. Of course, if we end up in a compound that has quaternary carbons, carbon that doesn't have hydrogens, then of course those carbons don't count. So you're looking how many different hydrogens there are, not different carbons. So be careful with line formula like this. If there was, let's say, one more carbon here, let me see. Let me share. See, this carbon that arrow points to. Let's make it smaller. This carbon that arrow points to is quaternary carbon. So that carbon would not count. And so when you were counting carbons, you wouldn't count this one as A, this is B, this would be C, because this methyl group is different from this one. This methyl group is attached directly to the ring, while this one to CH2 group. And then you would have two D hydrogens, then E and F. And again, you would have 6, because they would be different from the previous 6. So this carbon, so there are 7 different types of carbons, but 6 different types of hydrogens. And that's what you would be looking for. How many different types of hydrogens are there? Okay, any questions? Question number 7. In a bromination of 1-pentene with N-bromosuccinimide, NBS, for N-bromosuccinimide, you need to know formula of N-bromosuccinimide. It's given here under A. You need to know name, N-bromosuccinimide, and abbreviation, NBS. Same for chlorosuccinimide. It would be CBS. Which of the following is initiation step? That's question A, B, and what is the name of the reaction product? And C, what is the name of the product whose formation indicates that the reaction mechanism involves free radicals? So here is actually mechanism given under A, B, C, D, E. Those are actually reaction steps. And which one is the initiation step? So a free radical reaction consists of initiation step or steps, propagation steps. Propagation must be multiple steps, minimum of 2, as you will see here 3, and termination step, or typically termination steps. So initiation step is one in which free radicals are formed. So we start with stable species, and that stable species under some influence of something like heat or light, H nu indicates light, capital Greek letter delta indicates heat. So some stable molecule forms free radicals, species with unpaired electrons. So formation of free radicals from stable species is an initiation step. And this is the only one where free radicals are formed from something stable. So A is the initiation step. Propagation steps are those where reaction propagates, where one free radical gives different free radical. And so you can see that B, C, and D are all reactions in which one free radical reacts with some species to give rise to new free radical. Bromine radical gives, in this case, carbon radical, allylic radical. Then okay, actually, this C step is technically propagation step, but really it's not part of free radical reaction. HBr reacts with N-bromosuccinimide to give low concentration of bromine, which immediately reacts in step D. So that would be, so technically B and D are propagation steps. So you see carbon radical reacts with bromine molecule to give product, 3-bromo, 1-pentene, and bromine radical. And then bromine radical goes back to step B, and these 3 steps continue B, C, and D. And finally, termination step is one in which free radicals terminate. That's where 2 free radicals react with each other to give some stable species. There are other ways than 2 free radicals react with each other for termination, but that's typically the way it happens. So 2 free radicals react with each other to give a stable product. So I just mentioned what is the name of the product. It's 3-bromo, 1-pentene. This is the reaction product. And this compound, 3,4-diethyl 1,5-hexadiene, is dimer of the starting material. So this is starting material, 1-pentene. Formation of dimer indicates free radical reaction because only free radical reactions give dimers. If reaction is polar, it involves carbocations or carbanions, charged species, or cations and anions. And two cations, being positively charged, repel each other. So cations cannot dimerize because two cations, or anions also cannot isomerize because two anions also repel each other. Identically charged species repel each other, and they cannot dimerize. So only free radicals can dimerize, form dimer, something that has approximately twice the mass of the starting material, or twice the number of carbon atoms of the starting material. And so that's an indication that reaction proceeds through a free radical mechanism. So this question is about free radical reactions. Okay, so this completes a review of another short chapter, chapter 7. And again, before I move on to chapter 8, I'm going to stop this recording and answer any questions that you may have.